All right, problem 7. If number 6 was like the final boss of the game, number 7 is like New Game Plus, hard mode. This is one I made up, especially for you. Regions might not even do this, but hey, we're gonna go beyond the regions. Um, you got 2 triangles here. Well, actually, there's a bunch of triangles. There's technically, I think, 5. There's this small triangle right there. Okay. There's this small red triangle here. This small blue triangle right there. And you might be saying, well, that's it. That's all we got. But technically, there's still 2 more. And these are the triangles they want us to prove. Triangle DAC, right? This triangle right there. And I'm going to separate that. I'm going to pull that out so we can kind of see what we're working with. And it was D at the top, A down here, and C right there. Okay, that's our like 4th triangle, and then the 5th one is this one right here. A, C, E, triangle ACE, or however I wrote it up. But I'm going to shrink that down, and I'm going to also bring it out over here. I guess I'll let's see if we can get them next to each other. Shrink it and bring it up. Those are the triangles we're working with. We're trying to prove that those triangles are congruent. And, I'm going to start this just like I did with all of the others. I'm going to put the givens in there. And I'm going to put it into both diagrams. Not only are they telling me that this entire side, DC, right, from D to C, that's got to be congruent to this other side, AE, right, AE, from A to E. Right, that's a side fact. They tell me this weird fact that that small triangle, this triangle right here, is got to be isosceles with side AB congruent to AC. Right? A, B, and C. And if you remember, in an isosceles triangle, you have 2 congruent sides. And then a long time ago, we learned that the base angles, right? The base angles of isosceles triangles, the angles opposite those congruent sides, those angles have to be congruent. And that's the trick to this problem. It's, not something so obvious as a midpoint or perpendicular or parallel lines forming alternate interior angles. This is like something seemingly unrelated. Like you got another triangle. How can that help you find something else out about these triangles over here? And it's clever because when you put this back into the picture, you can see that you got this angle here, and that angle belongs to that blue triangle. Right? That angle is the angle at A. Right? It's this angle right there. Right? Not only is angle A in the blue triangle, when you come back here, in that red triangle, this angle on the other side of the isosceles triangle belongs to this red triangle. I'm going to pull that out so you can see. Right? That red angle is at C. It's right there. Boom. And that's the trick to this problem. It's a matter of, can you see how that isosceles triangle tells you these angles in the corner of the blue and this angle in the corner of the red, that those angles are congruent. Because if you can see that, you've got side, angle, and now you're ready for the last thing. And if you notice, they have the same base. The 2 triangles we're trying to prove, they've got a base of AC and AC. So when you put them back on top of each other, you can see that side is common to both triangles. AC is used twice. It is a side in this red triangle, so I'll put a red mark, and it is simultaneously at the same time a side in this blue triangle. So AC is congruent to AC. It's congruent to itself. And I'm going to show that here, reflexive. So I've got side, an angle, and then another side. And those sides include the congruent angle that we have. So this is going to be a side angle side proof. So if you have followed with me up to this point, let's go ahead and write that proof. If not, I encourage you to pause the video, rewind, and maybe take a look at this this little cheat sheet over here and see if that helps you with this. Or on your phone, Google search the isosceles triangle theorem to see where I'm getting those congruent angles. But we're going to write this up now. I'm going to start with my givens. So I'll go 1. I'm going to go with DC is congruent to AE. And that was a side fact, right? DC and AE. That was a fact I used in my triangle proof to prove that those triangles are congruent. This next fact, too, that's not a side fact for us. I know it says there are congruent sides. So triangle ABC is isosceles with AB congruent to BC. And I know that's tempting to say, oh, that's another side fact. But these sides, right, AB and BC, they're not in the triangles, right? AB looks like that. That's not a part of the triangle we're trying to prove congruent. AB just isn't there. And that's the same thing with CB, right? CB is not there. It doesn't count. It's not a side of our triangle. So we can't use them being congruent as a part of our side angle side. But what that does tell me, what you telling me that triangle ABC is isosceles, that lets me say that this angle here, and we'll do it in blue, this angle here, E to A to C. There's a bunch of ways you can name that angle, but angle EAC must be congruent to this angle over here, DCA. All right, DCA. I like to use the letters in the triangles that we're trying to prove are congruent. So DCA. I know those triangles are congruent, and for a very simple reason. Simple, but not necessarily obvious or easy. That's true because of the isosceles. I can't spell. Isosceles triangle theorem. And that's it. That's all you got to write. We'll understand you're saying, oh, if I've got an isosceles triangle, I know that the base angles must also be congruent, because that's what that's saying when you cite the isosceles triangle theorem. And those are angles in my triangles I'm trying to prove are congruent. And then my fourth fact was this reflexive property, that AC is congruent to itself. Because that AC is shared by both triangles. It's like the base of those two triangles. So that is the reflexive property. And that is a side fact. And I've got side, angle, side. So we're going to wrap up this proof, namely that triangle DAC must be congruent to triangle ECA. I don't want to mess that up, so I'm going to copy it, and I'm going to bring it down. Boom. That's my fifth. And I know those triangles are congruent because I got some SAS. I want to SAS that proof. Side angle side. It's a very appropriate way to end a hard problem. We solve it with some SAS. That's how you know you're an Ellias student. Give them that SAS. All right. I'll see you in the next one. Next Ellias Academy, that is. Thanks.